Hey there, this is Jake from the Chasing Quality Podcast. Thanks for joining me. Today I'm going to talk to you about making panel doors for cabinets. By panels, I'm talking about an inset panel using rails and stiles. We'll talk through the different styles a little bit. We'll talk about the components, the pieces. We'll go through Sketchup and get a little bit closer. And then I will show you how I do it on my router table. All right, so let's first talk about a couple different styles. Generally speaking, the components that you've got for a cabinet door are, you've got a rail that sits at the top, a rail that sits at the bottom, and a stile on either side. This would be a full square. And then you have a panel like this, that sits in between. This panel, the different styles, normally you're gonna have, these are 1x2s or technically 3/4 inch by 2 inches. The cuts on these can be slightly different. You can have a round over on the edge. You can have a slight miter to it. You can leave it just flat if these are more basic cabinets. You do all sorts of things with these with different profile bits to give yourself a nice aesthetic look to them. The panels on the inside vary. We're going to go with a shaker style today, which is one of the simpler styles, and that's just going to be a flat panel. Can be 1/4 inch, this is 1/4 inch thickness. Sometimes you can actually do a full 3/4 inch thick stock, and you've got it coved around the side, or you've got it mitered, or you've got it raised. You've got a bunch of different styles of the panel, but generally speaking, for the assembly, the rails that are at the top will fit into the stile using some sort of tongue and groove. You can make this with a Craig jig and pocket screws. That's actually probably one of the easiest ways to make cabinet doors. I just don't feel that those are quite as sturdy, because what's going to happen is over time you're opening and closing these doors. It will cause mechanical parts like screws and whatnot to possibly come loose. So generally you're going to want to cut a tongue on the rail and some sort of groove on the stile, and this will fit into this, and then you'll glue it. And that glue, along with the panel that sits in there, forms a very strong overall structure to the door. A couple of reasons why you would want to use panel doors as opposed to a flat, solid door. Part of it is style, aesthetics. I personally think that just a flat panel door looks pretty ugly. I've seen them before, and I just don't really like that. If you're going for a certain very, very clean look, like a modern look, you can make it look nice, but the whole system has to look good together. Otherwise, those plain doors are going to look not so good. But perhaps the more important reason is the movement of the wood and the integrity of the wood's dimensions and its straightness. If you've got, and I've got a piece here, if you've got solid wood, let's see if we can get this in focus here. If you look carefully enough, and you might not be able to see this, there's a slight bowing here. Not bowing as in the airplane, bowing as in like slight curve. There's a slight curve there. And what's happening is the top, I cut this not too long ago. This is a very dry piece, but it dried out even more once I cut it. This top part, being exposed to the air, gave up some of the moisture on this side. When it gave up the moisture, it caused the wood grains to contract a little bit. And so what's happening is you've got this wood movement, and this contraction of the grains, and it normally will follow the growth rings. You can't quite see the growth rings in this image here, but it's based on the growth rings. So like a solid door, if I were to make this, and this is small, this isn't very wide, this is about 9 inches. If I were to make this, your average cabinet door might be, say, 16 inches. If I were to make this 16 inches, this would have a very pronounced bow to it. So you really can't make panel doors, you can't make solid cabinet doors using real wood, using solid wood. You usually have to use some sort of engineered stock, either plywood or perhaps MDF. MDF doesn't make for a very good door though. It's just not structurally sound. It's got some good properties for other purposes, but for a cabinet door, if you're going with a flat panel cabinet door, you would likely use plywood. And it can be done nice, and plywood's not going to move. It's generally going to stay pretty stable and flat. But if you're using solid wood, it's going to bend a little bit. Now, one way that they often counteract that, or they used to counteract that, with glued up doors, is if you would vary the growth rings, vary the rings on these pieces. I don't know if you can see this. You'd vary it in a way that you'd have them bowing up, bowing down, bowing up, bowing down, and you glue up several pieces across, and then across the width of it, each of them would cancel out. The one would cancel out the next. You could also use quarter sawn. This one is quarter sawn. Let's see if you can see that. This is. Let's try to follow my eyes. This is quarter sawn stock. Quarter sawn won't move very much, so you could, in theory, do all quarter sawn pieces and glue it up, and you may get stability. But you're likely to still get maybe 1/8 of an inch bowing across it one way or another, bowing or cupping, and it's no bueno. But if you do it as a panel, that wood movement, you've got a slight bit of movement, expansion and contraction across this width, but it's so slight, it's like maybe 1/64 of an inch at most, and walnut doesn't move very much. And the same thing here, 1/64 of an inch back and forth. But you know, if it's in an air-conditioned climate and it's got a finish on it, it's likely to not give up or absorb much moisture. So that movement is up here, up and down, side to side, and across the whole thing, you don't really get much movement. And along the length of a piece, once it's dry, it's normally structurally sound. And it's not gonna bow. It's usually along the grain, along these growth rings, that it actually, I should say perpendicular to the growth rings, it will actually cup and bow. So if you make that a cabinet door as a panel door, rails and stiles, you have a very stable door over time. It's going to be stable. Now, I just showed you this. This is going to be a panel. I believe this is going to be a panel for a large cabinet, a large file drawer, and you have a slight bowing here. But once I have it fit into the grooves into the grooves of the rails and stiles, that's going to help to hold it and keep it from really bowing. It's bowing a bit right now, and that's probably because it's not. This is certainly not quarter sawn. This is a very radially sawn, and this is not the greatest piece. It's pretty, but based on the way the rings are oriented, we're going to get this bowing and cupping this along it. So, but if I build the door, if I build the drawer front correctly, it will minimize the impact of that. So that is why you would want to build a panel door. And one other reason it's worth mentioning, and this is only slight, but the panel doesn't add a lot of strength. It adds structural, maybe rigidity to it. It keeps it square or rectangular, perpendicular. You know, the angles are nice 90-degree angles, but it's not adding a lot of strength. However, you save a lot of weight. Because it's not adding strength, you save a lot of weight by reducing it to about a 1/4 inch stock. Now again, not all panels are going to be 1/4 inch stock, but if you wanted to go down to 1/4 inch stock, you can get 2 panels out of one piece of 3/4 inch stock by resawing them through a bandsaw and cutting them in half. And also, what you get from that is you get what is called book matching. Okay, so this was one piece that was cut in half, and then you get what is called book matching, where one side is the mirrored opposite of the other side. And that can look really cool on cabinet doors if you've got a pair of doors next to each other and you've got this mirrored image, especially if you're using something like walnut and you're trying to incorporate crotch pieces and knots and things like that. Some people don't want that, especially if you're painting it, you don't really care. But it does make the door lighter, a lot lighter, and it does allow you to get away with less stock if you're going with 1/4 inch doors. There are a couple ways to design these doors. Let's go inside and check out Sketchup and talk through the design that we're going to be using so you have a better idea of how these pieces are locking together. Okay, so here we are over in Sketchup, and I'm going to show you a little more in depth what a shaker style panel door looks like as far as the construction. We will go out and actually construct this but just to show you the pieces that are used to make up the door. This is kind of helpful, I think, when you're planning it out. Door panels, because of the measurements, adding and subtracting little bits here and there, I think can become a little bit confusing when you're out in the shop and you're trying to do these calculations, you know, fractional addition and subtraction. And so drawing it out in SketchUp first and maybe doing the measurements there can be very helpful, especially if this is your first time. Once it's a little bit old hat to you, you might be able to just wing it. Again, a shaker panel door is essentially you've got the rails at the top and the bottom. Okay, rail top, rail bottom, and the stiles that run up and down. And the panel is normally a flat panel, and the edges of these rails and stiles are normally mitered, a very slight miter, but nothing fancy. You don't have to miter them. If you're building this just for, say, your workshop or whatever, there's no need to really have to worry about mitering them. I built my kitchen cabinet doors out of a shaker style, or in a shaker style, and I use my router bits, which do cut a slight miter. And I think the miter looks a little bit nicer for, you know, something like a kitchen or anything like that. It's a very classy style. But again, generally you have 2 rails, 2 stiles, and a panel. And let's look at the way that these are actually cut and connected. You can do this on a router, or you can do this on a table saw, as I mentioned earlier. The router makes it very easy, but you can do it almost as quickly on a table saw if you know what you're doing and you have a jig set up to do it. So the components, I only have one rail and one style here, and then the panel. I didn't make all the pieces, but this will show you exactly what we're working with. So the panel, you can do this a couple ways for shaker. I recommend going with a 1/4 inch thickness, and you can make this solid, or you can use plywood, or you can use veneered MDF, or you can glue this up. There are multiple ways to create this panel, but generally you want the panel to be floating inside of the frame just a little bit for expansion and contraction, especially if it's solid. If it's solid, it's going to expand and contract just a little bit with the seasons. So you can do 1/4 inch. 1/4 inch, what that allows you to do actually is if you've got a thicker stock, like 3/4 inch stock, you can resaw it, cut it in half, and then you can have book matched pieces for 2 doors. Frequently you'll have a cabinet that's got 2 doors that are side by side, a pair, and if you have the panel that's book matched, it can look very aesthetically pleasing. But either way, you can either go with a 1/4 inch stock, or if you go with a 1/2 inch, then it would be a little bit thicker, and you would just do a rebate or a rabbit cut, as they call it, to cut this little notch here, to 1/4 inch, because that's what's going to slide into your rails and stiles. Okay. All right. So let's look at So what I have here is I've gone ahead and drawn on here what these cutouts are going to look like. So you've got a style here, and when we run it through the router bit for the stiles will cut this mitered angle here, and it will cut out this groove here. So when you use the paired bit, then you're going to cut a tongue. But let me show you what this looks like once you route it down again. Okay, so we start off with 3/4 inch by 2 inch stock, and this is all going to happen at the same time, but I can only do these one at a time. So it's going to cut this out here, and it's going to cut this out here in one pass, and leave us with that. Okay, and so you have a slight miter here. You've got this nice groove here. You also, while you're cutting the grooves for the stiles, you're also going to cut the grooves to the rails, because the rails also have to get the same grooves, and you'll see why here in a second. So let's go ahead and take those out. Okay, so we're taking out the groove here. Looks like I made a mistake on one of my. Let me cut it from the other side. The other side's actually a little bit better. Okay, and then we've got the little mitered cut here, and this cuts it all the way down here. So now you've got two. The rail and style looks exactly the same as far as the cuts so far. And let me go ahead and fill this back in so you see what the stock's going to look like once it's left. All right. But you're going to do a second pass for the rails and that's to cut the tongue end, both ends, the tongue ends of these rails. And once you do that, now you're going to come across it at a 90 degree angle. You're going to push this perpendicular to your tabletop, and so you're going to want a nice fence with a guide to do this and hold it straight. You're also going to want to use a sacrificial piece behind it, because what happens, and I'm not sure if you can imagine this, as you're pushing this across, this is going this way, the blade is turning this way, okay, turning this way. It is going to potentially rip out the grain right here on the back end if you don't have some sort of protection there. So you always want to have a sacrificial piece of stock backing this up as you're pushing it through through that router bit. All right, so it will look like this. It cuts it here, and it cuts it here, and I'm gonna have to fix a couple of these pieces here. So then what we're left with is, as you can see, this combination of tongue at the end, groove in the middle, or groove along the length of it, and this tongue fits very comfortably into here, into this groove. This miter is the opposite of this miter, so those fit snugly. You're left, this tongue is about 3/8 of an inch. This groove is about 7/16 of an inch. So you're left with about 1/16 of an inch for glue and whatnot, so that this miter fits perfectly here. And then, as you're assembling this, you'll take one stile and you'll put a rail into it. You'll take another rail and put it to the other end of the stile, and then you'll slip in the panel, and the panel will kind of float. You want it snug so it doesn't rattle, but you don't want it so snug that it can't expand and contract with the seasons. So generally you're not going to have much trouble. If you cut this to 1/4 inch, this groove is 1/4 inch, and they're going to fit nicely. You do want to make sure that the panel is about 1/16 of an inch narrower on each side, so about 1/8 of an inch across, than is the distance from this part of the groove to that same part of the groove on the other style. And that gives it some room to, again, expand and contract. So, once you're done, and of course we're going to cut out this other end too. We'll turn it around. Oops. We will turn it around in our router, and of course it's looking all jacked up here too, just like I did at the other end. Right. So that's how we essentially construct it. And for those who haven't worked with glue before, wood glue, especially like a Type Bond 3, and I always recommend Type Bond 3 when you're working with walnut, just because the colors match pretty closely. Glue is very strong, and generally stronger than wood itself. So with a joint like this, if you put glue on the tongue, on all 3 sides of this tongue, and a little bit here on the miter, and a little bit here on the back here, and you glue it to this, you're actually going to get a very, very strong joint, and you're going to have 4 of those, 1 at each corner, plus the panel, so long as you have it nice and square. By square, I don't mean squares in the geometric shape, I mean 90-degree angles around it. This panel will also help to hold this structurally together. So that is essentially the design of a panel door. Let's head out to the shop and cut it up. Okay, now as far as cutting these pieces up, to get the pieces if you're going to like your big box store, you can find 1x2s, and they're going to be nice and smooth, and they're not always straight. So check really carefully to make sure you're getting straight pieces. But you can get them cut to 1x2 inch stock, and that 1x2 is actually going to be 2 inches wide by 3/4 inch thick, and that's pretty much your standard for cabinet doors. So then you're really just going to cut the pieces to length. To determine the length, it's going to vary. It's going to vary a little bit depending on the style that you're going with. And if we're going with shaker style cabinets using the bits that I'm using, you've got a rail here and a stile here. Again, we have to have a tongue coming out of the rail, going into the groove on the stile, and that means that the stile is actually going to run the entire length of the door. So that's really just generally the height of the door. If it's inset, you're going to need to subtract about a 1/16 of an inch, maybe an 1/8 of an inch, so it fits into that door opening, you know, with a slight gap. But generally speaking, it's going to run the full length of the door. The style, or the rail, however, is not going to run the full width of the door opening. Sorry, it is going to run the width of the door opening minus the width of each of the styles combined, the sum of these two styles. But remember, we're going to have tongues cut into the rail. So if we've got tongues cut into the rail, we have to determine how deep are the tongues, multiply that by 2, and then that gives us the actual, and then add that to the width that we need, because it's going to set in there. So it's kind of it's not really complicated math. It's pretty easy math. What complicates it is that you're working with fractions, and I know that I need the. Okay, so let's say the entire door opening width is 16 inches. This is 2 inches. This is 2 inches. Okay, so 16 minus 2 is 12 inches. This isn't going to be 12 inches though. I actually have to add 7/8 of an inch to the width of this, or the length of this, because I'm going to cut back on each side 7/16 of an inch for the tongue. So that's something to keep in mind when you're doing this. And it's the same thing with the panel. The panel actually needs to be, because the panel around the inside is going to be set into grooves along the inside. Those grooves are going to be probably about 7/16 of an inch deep, but you're not going to want it a full 7/16 of an inch deep. You're going to want the panel. You're going to want the panel to set in about 3/8 of an inch on each side. That way, it gives you a gap on each side of about a 1/16 of an inch for seasonal movement. So this is where Sketchup is really handy. If you haven't made a lot of cabinet doors, Sketchup is incredibly handy for making sure that your measurements are accurate. I did a lot of math, and I've got all of these marked out and ready to go, and these are all cut to length. So now I'm able to take these over to my router table and run them through as they are, knowing that they should fit and become the dimensions that I wanted them to be. Now, the one challenge I'm going to have is that the measurements I was using were the measurements of the actual door opening. So I know that I'm going to have to cut off probably an 1/8 of an inch on the top and the bottom. Sorry, probably a 1/16 of an inch on the top, a 1/16 of an inch on the bottom, and a 1/16 of an inch on each of the sides. So a total of 1/8 inch side to side, 1/8 inch top to bottom. And I'm okay with that, because there's nothing worse than having a door that has too big of a gap. So I've learned to kind of cut it to the exact dimension of the door opening, and then I will shape it and cut it down later to size. So you can sand these ahead of time, but I would recommend that you run them through your table saw or router first to get your tongues and your grooves, then sand, because you're going to have a little bit of chipping on the sides. You're going to have a little bit of roughness, and I just find it easier to sand after running them through the router. However, you likely do want to sand before you assemble it and glue it up and put the panels in there. Because once you have the panels and stuff in there, it is really hard to get into some of those nooks and crannies. You still have to sand a little bit once you've assembled it, but that first pass of sanding for your coarser grit, your 60 grit, 80 grit, 120 grit, is probably better done before assembly. And then once you've assembled it and you've got kind of the glue all cleaned out, then you can run up 160, 200, 300, whatever grits you plan on using for that purpose. This is walnut, and so for the gluing I'm going to use Titebond 3, because it kind of dries to a brownish color, and I think it goes really well with the walnut. Titebond 3 is very strong. It's going to create a very stable, sturdy door, and they should last 50 years, I assume. All right, so let's real quickly talk about how you can cut up these cabinet doors. When I first started, I did not have a router table. I had a small handheld router, but you never want to use a small handheld router to cut up doors. It's just not sturdy enough, stable enough. You need a stronger router, 2.5, 3 horsepower. A table with a nice strong fence is what you want for cutting up these doors, especially if you're going to use these bits. And I'll grab the bits in a second. What I started off doing initially when I started with woodworking, is I was doing these on my table saw. I was doing both raised panels, and I was cutting the tongues and the grooves on my table saw. And it's not a bad process. It's definitely cheaper than buying a router table and getting it set up. It's not as exact, and it can be a little bit frustrating, but it's definitely doable if you're working on a small project. So how you would set it up for the, let's say you're cutting the rails, the groove, is ideally you'd be using a dado bit, a stacked dado, and you would stack that to a 1/4 inch thickness, and you would just run this, straight down over top of the blade, and it would cut the groove right down the center. Now, as far as cutting if you wanted a mitered edge to it, that's where table saws start to get more complicated. You can definitely do a mitered edge on a table saw, but the challenge is when you go to cut the tongue on the matching piece, then you have to worry about back mitering to fill in the front miter on your style. So I would say a table saw is definitely an easy way to go if you were just going to leave these flat. But if you want to do mitered edges, you may want to consider investing in a router. Again, I have done this before, and you can do what they call these haunched pieces, where you kind of cut this down a little bit and work with it. And you can do that, and there are all sorts of books on that. But it does eventually get complicated very quickly on the table saw. And once you start getting that complicated, again, if you're doing like 1 or 2 pieces, it's fine. But if you're going to build a bunch of these doors over time, get yourself a router table, get yourself 1 or 2 bit sets that match the style that is your preference, and go that direction. So you cut the tongue, and then if you're to cut you cut the groove, and then to cut the tongue for the rails on the table saw, that's a little more tricky. You can go at it. You can put this against a sliding miter fence or miter gauge, and you can push it across, and you can take little passes at this, cutting just to a depth that gets you right to your tongue. That works. It's not ideal because you end up getting like a little bit of it's not chipping, but you get little tiny fine grooves in there. A little bit better is to use the stacked dado again and go with a thicker stack, 3/8 inch stack. If you run a 3/8 inch stack, this over a 3/8 inch stack, and you take it in a 1/4 inch, that gets you out a 1/4 inch in the bottom, and you flip it over, run it again, gets you a 1/4 inch out on the bottom, on the other side, and then you're left with a nice 1/4 inch tongue that is 3/8 of an inch deep. That's one way to do it. Some people will build a jig to run it, perpendicular, standing up perpendicular to the table and running across this way. That's another way to do it. I'm not really sure if one way or the other is better. I would say that they can both be dangerous, but the standing up method is definitely a little bit more dangerous in my opinion. And then if you're for the panel, just get it to a 1/4 inch thickness, and it should fit in all your grooves. Now, if you want that panel to be a little bit thicker, you may have to rebate or run a rabbet. They call it a rabbet rebate, depending on what country you're in. Run that rabbet along the backside to at least cut the edge so that it's a 1/4 inch. You can leave like the middle of it thicker, 3/8 of an inch, 1/2 inch, or whatever, and then it'll fit in there. Now, if you're going to use pocket hole screws, which is a fine way to do this for utility cabinets, like if I were to make a bunch of doors, and I am going to make a bunch of doors in here in my shop, I could use Craig screws. I'm not going to. I prefer the method that I've learned over the years. But to do that, you would essentially just drill your holes here in your rail at either end, and you would line these up nice and perfect and perpendicular. You want to make sure that it's perfectly square perpendicular with something clamping this, an edge clamp, and then you just screw it in. And honestly, you don't have to wait for glue to dry. You don't have to glue it. You don't have to run it through your saw or your router. It goes pretty quickly. The one challenge with that is that you still need to have a groove run through the inside of each of these pieces. Now, if you run a groove through through your style, and you have your rail attaching with a tongue, that tongue fills in the top of the groove, so you don't have a gap. But if you're using Craig screws, you're not using tongues, you're going to be left with a 1/4 inch wide by 3/8 inch deep gap right here. And that gap can be a little bit ugly. So what a lot of people do is they'll plug it in. They'll create little pieces of wood and they'll kind of plug it in, and that's okay. But just keep that in mind. Again, these are probably utility cabinets if you're using pocket screws. But something to be aware of is that could happen. I have done that for doors. They turned out okay. They're still strong, but it does come with some complications. Standard doors, high-end cabinet doors, generally are tongue and groove. All right, so we've talked about the table saw a little bit and the dado blades. Let's talk about the router bits, because this is what we're actually going to be using today. Router bits come as these 4 cabinet doors come as a set. This happens to be shaker style, and shaker is it's kind of an austere, but classy in my opinion, simple look. I like that. It fits the country nature, country theme, I guess, of our home. You can get these in much more complicated designs to cut raised panels. You can have them rounded over and all sorts of different designs. But generally, you're going to have 2 bits, maybe more, but generally 2 bits. You're going to have one cutter bit for the slot cutter, and you've got these teeth here. These will cut out the groove. Okay, cuts out the groove, and at the same time cuts a miter edge. That is probably 20 degrees or so, maybe 30 degrees. It will cut this mitered edge at the same time that it cuts the slot to create the groove. All pieces are going to get a pass using this bit. The rails they're going to get passed over 2 bits. The stiles only get passed over this bit once, and that's it, because we just need the groove along it. Once we've done that, we've cut all the bits using, once we've cut all the pieces using this bit, then we come back with this fatty, and it is fat. I mean, it's a little bit heavier than this guy. This is a fat bit. This bit will cut at a 90-degree angle. It will cut out the tongue. Cuts out the tongue right there. And if you notice, it also has a mitered cutter here to cut the reverse miter to fit into the other miter, the front miter, the forward miter that we have on the stile. So because you are running this across at this angle, perpendicular to the fence, you're going to be using some sort of miter gauge, and you want a very straight miter gauge, and you're going to want to back it up with some sort of sacrificial stock. I'm not going to use a piece of this walnut to do it. Well, I may find a scrap piece of walnut. But the reason you're going to want to do that is because as you're passing this over the bit, and this bit is rotating at several thousand RPM, it's actually going this way, it's going to be going that way. This bit is cutting, and it's cutting, and I don't know if I can get a very good angle on this. It's cutting. As it digs through here and cuts this out, you're going to get chipping. You're going to get blowout, what they call blowout here, or chip out, on the back side of your stock. And so if you use a sacrificial piece behind it, that creates a surface against which the bit can create a clean cut. It creates like a scissor cut, if you will, and it keeps that blowout, that chip out from happening. And then what you can do is you can actually just use that sacrificial piece over and over and over again, because it's going to have that same exact cut, and you don't have to keep using sacrificial pieces. You just use the same sacrificial piece. But that's very, very important, because you will very quickly ruin your rail pieces if you don't have some sort of backing for it. I have made that mistake one too many times. So that is that. Now, when we go to set this up on the router table, we want to make sure that these are perfect. By perfect, I mean perfectly centered, for example. We want this piece, this bit, so that we've got 1/4 inch on below and 1/4 inch above. That's very important that we've got that measured. But more important than this bit is aligning this bit, because you can have a slight variation. You have a 1/16 of an inch off in one direction, and it's not going to necessarily cause any problems. However, if you've got this bit off and not aligned to wherever this bit was, your pieces aren't going to fit properly, and you're going to have uneven face frames, and you're going to have to go and sand and sand and sand and sand and sand. So what you're going to want to do is you're going to want to do some test pieces first. Try to get this one as exact as possible where you want it. With this one, you're going to want to make sure that you are running test pieces as well, and that you're connecting those test pieces together to make sure that that your cutting is good. I use this device, this crank, that raises and lowers my router in the table, and I can get very precise measurements, very, very small measurements that I'm able to adjust to. So that comes in very handy. You don't need that. You don't have to have that, but it does make it a lot quicker, a lot easier. And then the last thing that you're going to want is some sort of dust collection. I've got my router table set up with two dust collection ports. I've got a port that's in the fence that pulls some of the stuff from the top into my dust collector, and then I've got another one down the bottom below where my router is to suck that stuff in as well. And those go into a Y pipe, and then it goes up into my dust collector and up and over. The number of doors and drawers that I need to cut today, they're quite a few, and it's going to make a lot of mess and a lot of chip out, and so you want to make sure that you're pulling that out. And then do be aware of overheating if you're going to run these for too long. The router I've got is a pretty good one. It's a Porter cable. Porter cable makes really good routers. But if you're doing a lot of this, you do maybe want to give it a break from time to time and not overheat it. So let's go ahead and head over to the router table and start getting set up. It's seen a good amount of use, but what I like about it is that it's got this locking mechanism that locks the spindle from going up and down, and it's got this very fine adjustment here. If you see here, 0, 1/64, 1/32, 3/64. It's got some very fine adjustments. So it's actually so this sits into the router table. It wasn't too hard to set up, but it was kind of complicated. And then I got this Pro phenolic tabletop. I got this probably through Rockler many years ago, and then I custom built this setup below, and it all connects to a sanding table. And then this connects to my, at the other end, it connects to a sanding table. I don't use this as much as I used to. I really need to start using it again. This is a downdraft table. If you see down there, I've got pegboard, and then I've got a way to connect this to my dust collector, and it will suck all of that dust down in there. So if I'm sanding something, it keeps it out of my mouth, my lungs. All right, back to the router table. So as I mentioned, I've got a dust collection port here on the fence. Underneath there is a dust collection port down below. I've got a nice large start and stop switch here right at knee height. I find it kind of important to have start and stop switches at knee height. All of my major tools, I guess my three major tools, my most dangerous tools, which are my table saw, my router, and my jointer, that's at knee height. And so I can quickly, without letting go of my workpiece, just bump it with my knee and stop it really quickly. So we're going to need to pull out this. We need to pull out this insert here, take this bit out. The bits we're going to be using they've got a 1/2 inch diameter. So we need to take this out, take out the collar, take this out, and we're going to get it all set up. These little pieces are handy. They are 1/4 inch by 5/16 of an inch, and it allows me to make sure that the bit is exactly where I want it as far as height and depth. So these are handy to have. Otherwise, if you don't have these, you can either cut your own or try to measure it out. I find these to be a little more exact than trying to use like a tape measure or so. So at this point, we're gonna cut a test piece Get our eyes on, ears on.
Exotica.
Okay, so that test piece came out very, very nicely in my opinion. It was slightly thicker stock. This was almost 7/8 of an inch stock. So you'll see that the groove, if I can get it to stop focusing on my eyeballs, you'll see that the groove, oh, I step over here, there we go. You'll see that the groove, I'm trying to get out of the picture here. There we go. You see that the groove is a little bit off center, but that's okay. I just wanted to make sure that it's cutting very nicely, which it is. It's cutting a nice groove for us. And now I think that I can go ahead and run all the pieces through. And because this is part of a larger project, you're going to see me running through several dozen pieces. And I'm going to do that because I can get all this done in probably 20 minutes. I can cut all these pieces in maybe 20 minutes or less. And then switch out the bit for the tongues and go from there.
Exotica. Enter the world of Exotica. Be a dice of Exotica.
Okay, so that went pretty well. I did make one mistake. You may not have noticed it. A couple of doors, I'm making them split panel, which means that there is a stile that runs right down the middle. And that stile that runs right down the middle actually needs grooves on both sides, and it also needs tongues at the top and bottom. And I got ahead of myself on one of those sets, and I cut the center piece first, and then the next piece I went to cut, I accidentally cut grooves on both sides, so I had to go ahead and cut myself another a piece to replace that one. But I cut up, let's see, 1, 2, 3, 4, 5, 6. I think that was maybe 8 sets, the grooves, and the grooves didn't take me very long to cut once I had them on the table. It was maybe 15 minutes. One thing to be careful of as you're doing this is, it's not really to be careful of, it's be mindful of, is you want your best face of that piece of stock to be, outward. You want that to be the exterior, and the face of it is going to be down on your table. The outward face is going to be down on your table. So you may have noticed that I was sitting there looking at both sides, and when I was doing that, I was looking for the best side, and I put the best side down. There were a couple pieces. Let me grab a piece. Here's a good example. There were a couple pieces like this one that had a little bit of sapwood still running through it, and as pretty as that can be, I'm not really going for that look on these cabinets where I'm going to have a bunch of sapwood and heartwood mixed through. There are going to be a couple spots where there's sapwood, but for the most part it's going to be just heartwood. And so I didn't really want that to be too prominent, so I put that to the back. And so by back is that face is going to be up, and what's going to be front is going to be down. And you can see that it cut the mitered edge there on the top piece. So I was looking to see which piece was the prettiest or the smoothest, and I put that one down. There were a couple pieces where, and walnut's kind of prone to do this. Other woods are prone to do it as well, but I find walnut does it pretty frequently. If you've got a heavily figured piece and you put it through the planer in the wrong direction, the planer blades may actually cause slight, I guess burring maybe is what you call it, or frays the grains a little bit. And that can be really hard to sand out because you have to take so much off to sand that down. Even if it's only like 1/32 of an inch, that's actually a lot of sanding. So anything that had a kind of like a rougher side to it, that ended up being the backside. Backside is what is up when you're putting it through the table saw. So, or sorry, through the router table. So now we need to switch out bits to cut the tongues, and then we'll run the pieces through for the tongue. That's a little bit more challenging. It's actually, in my opinion, a little more nerve-wracking because you want to make sure that you want to make sure you've got the right pieces. You want to make sure that you've got the rails that you're doing, not the stiles. And if your doors are closer to square and you're trying to remember which pieces were the stiles, which ones the rails, you kind of get mixed up, and then you accidentally cut the wrong pieces. So believe it or not, it can be a little bit stressful. So you want to make sure you have it all laid out, especially if you're making multiple doors. Go through and lay them all out. Make sure you think about it. Make sure you grab the two pieces, the two rails. If it's a split panel, then you're going to have two rails in a stile. Grab the right pieces for those tongues, and grab a couple sacrificial blocks and start pushing them through. We are going to run a test piece through to make sure that we are set up properly, but let's go ahead and get the table retooled.
Exotica. Exotica. Enter the world of Exotica. Be a dice of Exotica. 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 Exotica is the music. Exotica is the music.
Okay, so this is a good example of what the panel now looks like. This is one of the split panels. I still have to glue these up and get the panels put in, and I need to sand them. But you see how the center stile has both grooves on the sides and tongues at the ends, and the rails have both a groove through one side and then tongues at the end, and then the stiles just simply have a groove. Stiles have a groove cut in one side. Then it all fits together, and when we glue it at those joints, it will be nice and strong. It's got a good gluing surface, and so that's what we'll do next. We're going to sand these up and then assemble and glue them.
Exotica.
Okay, so we've got this first this first door. We've got all the pieces sanded up for it, and I've got it dry fitted. None of this is in here permanently, but I dry fitted it to make sure that everything is going to fit properly before I start gluing it. But you have now a pretty good idea of what it's going to look like, and I guess we sort of looked at that yesterday. So I'm going to get my clamps, and I'm going to get a brush and my glue, and I'm going to start gluing this up and clamp it. And I do also need to grab a square. I've got a nice large metal square, because you want to ensure that this thing is as square as possible when you clamp it, because once that glue dries, it is dry.
Exotica.
And there we are. We're all done with the door. The one challenge that you have with a split panel door is making sure that the middle stile is even across, because you're going to have you want a little bit of a gap with the panels, and so you have to make sure it's properly spaced. So you saw me spending a lot of time on adjusting the panel, making sure it was square, moving things around. It's not perfect, but it will do. And once I clean it up a little bit finish sanding it and get it finished, I think it's going to look pretty nice. So there you have it, a panel cabinet door, in this case a split panel cabinet door. All right, well I hope you found that informative or interesting, or maybe you could just make fun of me, that's cool too. If you haven't checked out our podcast, please do. Chasing Quality Podcast. You can find us on Stitcher, Spotify, iTunes, all those major podcasting platforms. Until next time, keep chasing that quality. You know I will. Bye.